So on the homework, when it says to graph, please graph. Calculators out. Calculators out. Get them off to the side for me. Just off to the side. We're going to use it twice during today. That's it. Just put them off to the side. Brand new unit, totally different from last unit. We're going to reflect, rotate, translate, dilate. We talked some of that already this year. Where did we talk about these? Which three did not change size or shape? Which three transformations did not change the size or shape of a figure? Just go ahead. Rotation, translation, and a reflection. All right. We actually, and I don't expect you to remember this, but we actually had a term for those three. If they do not change the size or shape of a figure, we called it I don't know if anybody remembers, rigid motion. All right, rigid motions. They preserve the length and the angle measurement. We did talk about a fourth one that did not preserve the length. And what was that? That's a dilation. But if you remember, dilations preserved what? Maybe not length, but angle measures. Angle measures are the same when you dilate. And then two new vocabulary, maybe not new to you guys, but new to some of you. When you start out with a figure, your original figure, before I do turn it, slide it, flip it, before I do anything to it, the original figure we call the preimage. That's what I start out with. All right, the preimage. After you do something to it, you flip it, turn it, blow it up, shrink it. Then it's called the image. So I start out with the preimage, I finish with the image. All right, real quickly, down at the bottom, I got two figures. Does it look like I performed a rigid motion or not? Yes or no, and then back yourself up. Remember, rigid motion preserves length and angle measure. Does it look like a rigid motion was performed between these two? Yes or no? Here you go. 28, yes or no? Do we have one? Nope. Perfect. 23. Does it look like a rigid motion was performed? Not here. Perfect. Again, 3 for 3. 21? No, why not? Yeah, this is a big no. That wasn't a rigid motion because size changed. Yeah. Length and angle measurement stay the same when a rigid motion is performed. What about 2? If you eyeball 2, does that look like a rigid motion was performed? Do we have a 20 in the house? Size and shape remain the same. All right, so we all good. I'm going to keep bringing up that term over and over again this unit, rigid motion. Size and shape does not change. Okay, the one we're going to talk about today and tomorrow, one rigid motion we're going to talk about, reflection. Reflections. All right, flipping a figure over a line. We always have symbols and abbreviations here in math. Always, always. Same thing for reflection. If you know a reflection's going on, you're going to start seeing a lowercase r. Lowercase r. Why not an uppercase r? That's used for a different one. Okay, lowercase r says reflection, reflection, reflection. Then you will also have something written below it, it's called a subscript. So let me just write in y-axis right now. What is this notation telling me? Lowercase r was what again? So this tells me we are doing a reflection through what line? Y-axis. So reflection over the y-axis. So whatever subscript is here, that's the line I'm going to reflect over. All right, let's start reflecting. Start reflecting now. We're going to use the point A, which is 2, -1. So if you could just graph that on the next page, on the graph I provided. 2, -1, and we're going to do a bunch of things to that point. So go ahead, graph 2, -1. Call it point A. We're going to do a few things to it. So there's point A. First thing, lowercase r again for, I'm going to beat this home today. Reflection, but now I want it over the x-axis. So take this point, reflect it over the x-axis. Now I'm going to take this slow, even though I know most of you probably, boom, can plot it like that. When you reflect, distance stays the same. Distance stays the same. How far is it from point A to the x-axis? 1 unit. So wherever you put the image of A, it also has to be 1 unit. But now I'm going in the opposite direction. So I was 1 unit away. I go 1 unit in the opposite direction. Anybody? I don't want to call this point A because I already have a point A. A prime, yes. A with this symbol, which is the prime symbol. Name that point, everybody, now. I'm going to ask somebody, what is the coordinate of A prime? 2, -1 went to 24. 2, 1. There you go. Graphing it and writing the coordinate. Graph it, write the coordinate. All right, go back to 2, 1 now, but now I want a reflection through the y-axis. So now count the number of units it is away from the y-axis. And go that number of units in the other direction. And let me know what A prime is now. Not double prime. Double prime would be if I did something to 2, 1. All right, this is still going to stay A prime. What's my new coordinate? 29, going through the y-axis now. -2, -1, great job. That's middle school stuff. Here's where we are right now. I'm going to skip over to y equals 2 now. Reflect over the line y equals 2. First discussion we need to have, where the heck is this line y equals 2? Anybody know what type of line y equals 2 is? Yes, it's a straight line. Yes, I know that. Let's get more specific. Y equals 2. Caleb, what do you got? Say it again. Horizontal line going through 2. All right, horizontal line. So it's going to look, here's the line I want you to reflect over right there. Y equals 2. Horizontal line going through 2. Distance does not change. So everyone go ahead, count the distance from A to that line now. We're going to reflect over. Count the distance. How far away are they? 1, 2, 3 units. So I'm going to go 1, 2, 3 units in the other direction. Name that point. Name that point now. What do you got for that point? 2. What do we have? 2, 5. Common mistake. Everyone, take a look. Everyone, even if you got 2, 5 or not, take a look. Common mistake when we start reflecting through horizontal or vertical lines, kids start counting from the line. So they would have maybe told me this point was 2, 3. Always start from, count from the origin, remember. I'm going to drive that one home. Count from the origin. Quick question before I go on to this last one. What if I wanted a vertical line? That would be what? X equals a number. All right, X equals a number would be a vertical line. All right, now we come to this strange one. Reflect over this line, y equals x. All right, y equals x. Go to your calculators right now. That's why I had you get them out. And go to your y equals screen for me. And graph in y1, just y equals x. So in y1, just graph y equals x. Hopefully somebody or you haven't been playing around too much with it, and you can see what that graph looks like. That's the line I want you to reflect this point over. That line right there. How the heck are we going to do that? This line right there. How are we going to reflect A through that line right there? Well, I kind of have an idea where it's going to be, right? It's probably going to be somewhere over here when I reflect it over, somewhere over here. Yikes. What's up, Caleb? Okay, here. So you want me, okay, like where though? Like it intersects here, here, here. See what I mean? So you just want me to go up here and then over? Okay. What happens if my line wouldn't hit nicely like that though? Okay, so you got 1, 2, 3, 1, 2, 3. So you want me to go right there? I like that. All right, I like that. So that point would be -1, 2. Can anybody tell me a rule? Because that's how I like to do this. Instead of counting, I just like to remember a rule. Look, 2, -1 went to -1, 2. If I'm going to reflect over the line y equals x, what do I do with my coordinates? What do I do with my coordinates? Switch them, flip them. Okay, so hey, anytime you're going to reflect over this line from now on, we can just flip the coordinates. All right, flip them. Y equals x, flip them. All right, flip the coordinates. All right, I'm going to walk around watching you guys graph and label the points for this triangle. All right, where you reflect it over the y-axis now. So what's A prime? What's B prime? What's C prime? Good, just making sure everyone's doing over the y, not the x. Count the distance, remember, count the distance from the y-axis and go in that opposite direction. I'm gonna wait till everybody's done so we can make sure we got this done. If you guys want to work ahead, that's fine. Okay, give me those new points, please. Give me those new points. 26, yes, no? 26, give me my new points there, Jack. A prime. -1, 6. B prime. And C prime. Good. All right, any issues there with those and graph correctly? -1, 6, -4, 3, -2, 1. All on this side. All on this side. Okay, moving on. More practice with the vertical and horizontal lines. So everyone go ahead, 0, 5. Make sure that's on the y-axis. 0, 5, point X. X equals 2. What type of line are we working with? Vertical, vertical, vertical. There it is right there. X equals 2. Count the number of units over. Go in the opposite direction. Let me know where x prime is. Five. When you're ready there, Fiona, where's x prime? 4, 5. Yep. I don't know if anybody had 2, 5. Count from the origin, not from the line. Count from the origin if you had 2, 5. All right, count from the origin. All right, reading, reading, reading. Reflect x prime. So I'm not going back to 0, 5. I'm going to stay right here at x prime and reflect this point through y equals -3. What type of line are we working with? Y equals -3. Horizontal now, going through -3. Oh, I'm so sorry. You ran out of graph. I think you can still handle naming the point. I wouldn't expect you to graph it, but you can still name this point. Okay. 1, 2, 3, 4, 5, 6, 7, 8 units away. So go 8 units in the other direction. What's up, Billy? Question? So would this be x double prime? I'm just getting to that. Thanks for stealing my fire. Yes. Because I am transforming x prime, it becomes x double prime. Nice job. And what is that new point, even though I can't graph it? 19. 4, -11. Look at that. We could handle it even though we didn't have space on the graph. All good. All right, we just reflected a triangle. How about a line segment now? Graph line segment FG. Where am I asking you to reflect? Which line? Y equals, it says right here, now reflect through the line. Y equals X. Remember the rule. Go back if you need to look. What was the rule for Y equals X? What should I be doing with these coordinates? What was our rule? Remind us of the rule again. 2, remind us of the rule. Flip them. 3, 0 becomes 0, 3. 4, 3 becomes 3, 4, and graph. And I don't know if some of you are having little second thoughts. You're like, that doesn't look like it got reflected. Remember what this line looked like? Right there? Yeah, we reflected it. Looks good. Okay. I know they seem pretty close, but that's the line we reflected over. And now take the same FG coordinates and go y equals -x. Go to your calculator. I want you to see what this line looks like now. So clear out y equals x from y1 and type in y equals -x. And look at that line now. All right. So now I'm looking at this line. Well, I'm not going to flip them anymore, right? Anybody got a suggestion? Well, let me use Caleb's idea, and then you tell me what do I do with the coordinates. And you guys are probably going to be right. So I'm just, from F, I'm going to go 1, 2, 3. So where do you want me to go from there, Caleb? Well, if I go right, so you want me to go 1, 2, 3, 1, 2, 3 here? Okay. So that point's what? 0, -3. Okay. 0, -3. There's a problem though. That's not my point. Okay, so counting I don't think is going to do it there. Okay, because that's not my point. What were you guys going to suggest? So just change the sign. Okay, and that's where that one just, oh, so you're saying 3-0 go to -3-0? Close. We're almost there. Claudia. Okay, we're still, hey, take a look. If I get rid of the negative, what's there still? Y equals X, which I do what to the coordinates? So it's the coordinates are still getting flipped, but now I'm going to change the sign as well. So when you reflect over the line Y equals X, yes, you flip them and change the sign. So what would 3-0 become? 0, -3. And what would 4-3 become? -3, -4. So maybe we were right, Caleb. Now that I look at that again. And then go ahead before we end it. 1, 2, 3, F prime, G prime, 1, 2, 3, 1, 2. And there it is. Last one you're going to try on your own. You find the line I reflected over. So number 4, graph both. You find the line I reflected over. All right, what line were we reflecting over? 23? 11? X equals 3. Yep. Why'd you pick X equals and not Y, Fiona? Just a quick question. There you go. It was a vertical line, so that's why it was X versus Y. All right. Graph means graph. Tonight on the homework, graph means graph. You can get started on that. Compass tomorrow. All right. Grab a book. If you want actual graph paper, not what I provided in the back, there's some on the middle shelf over there if you want to take those. All right, let's get going here. This is not going to be an option.